Brooklyn, New York City. So I am on Eastern Standard Time. So I am so happy to be walking you through some introductory database concepts and databases. So we're going to go ahead and get started. So today we're going to cover why data is such a precious resource, why it's so important today, why folks love to use it in the cloud. Then we'll go into some specific types of ways data is managed. First, we'll look at databases, first relational, then non-relational. Then we'll look at some other ways data is represented in the cloud. Then we'll continue with a demo, and then we'll wrap up. So you've probably seen this photo before, but this kind of speaks to how precious of a resource data is. So normally when you need to store data somewhere, it's usually stored on a server. But many companies and other platforms and applications rely on things called the data center, and these are just basically facilities, just like a building, which manages all the hardware for you. So the server is usually that piece of hardware where the data will be stored. So because if a server has, if there's a lot of data in a company or a company managing a lot of data, it's a lot to maintain on a server in a house or in a company. So they rely on data centers to manage this data for you. So in this picture here, one of the things about data centers is that they take up a lot of resources. We're talking power mostly, and also just space. And so what this experiment here that Microsoft researchers went to kind of look at is how to reduce the carbon footprint in these data centers. So this was taken, I believe, around this summer, and this is off the coast of Scotland. And what they did is they took this data center and put it underwater to test for 2 years. And I believe this was done in 2018, and over 2 years, they kind of measured performance. And this is them taking it out, and they realized in their findings that this was a really great, efficient way to manage a data center. So what that means is that it'll be very interesting to see how data centers evolve over time now this experiment has come out. So data is, again, an important research source, and it's so important because so many of us are on the internet. In fact, 2/3 of the population are on the internet. That's 4.6 billion people, 200 million emails per minute. Out of that population, 3.7 have active social media accounts. So that's about 480 tweets a minute and 60K Instagram posts per minute. And out of that, 2 billion people shop
1, 2, 3, 4, 5, 6, 7, 8,
online.
9, 10, 11, 12, 13, 14.
95% of all purchases will
17,
be made
18,
online.
19, 20, 21, 22.
And finally,
23, 24.
By 2025,
25,
keep in mind that's 5 years from now, it's predicted that all this
Whoa.
data that is kind of moving around the world is going to reach 175 zettabytes. I've never heard this measure before, so it sounds pretty huge to me.
What's that?
And it's so huge, in fact, that it'll take at least 1.8 billion years to download. So that's a very, very long time.
Yeah,
so as you can
hilarious.
see, data is all around us. It's in abundance, and we have to know ways and have ways to be able to work through it, sort it, and analyze it efficiently. So one of the ways that a lot of people rely on is the cloud to store their data for them. So the story of storing data in the cloud also starts with the data center. And what is so great about having someone else manage, or another way to manage your server, is that any devices and machines, they need maintenance over time. So think about your cell phone. Whenever you need to make an update to the firmware or the operating system on your phone, you have to run an update. So, normally I have an iPhone, and normally the way that works is that I have to, wait for it to install and then restart. And so same case with a lot of our computers and any other devices that we use. And the same thing with the server. But the benefit of using a data center or specifically the cloud is that these things happen automatically. So any software maintenance, any hardware maintenance happens automatically with the intention of no interruption. So say that someone might be accessing data somewhere on a server, and maybe somebody who's working in a data center is doing some updates or fixes to hardware in that data center. The people who are using that data should not realize or not notice any interruption. And in the same way, when things are going wrong, fault tolerance, this term that we use to talk about managing disasters or when things go wrong, is supposed to be able to support situation where these things go wrong. So for example, if one of these data centers were to go down, you should have a copy of your data in another data center, either somewhere else in the data center or in another data center, so that end users, including yourself, are able to access your data without any interruptions. This also is great for when you have high traffic situations. We call that scalable. So this data is able to reach the demands of either from 1 to million number of end users. Also, when you are trying to access a file of a different type on your phone, for example, let's use Excel. So in Excel, you usually use the Excel app either in the browser or on your computer, and say that you want to look at this spreadsheet on your phone. So yes, you could look at it in the browser on your phone, or you could download the Excel application onto your phone and be able to look at it through there. So in the same respect, a server will need different types of maintenance and also different configurations to be able to support different data types. And the benefit of the cloud here is that all of that is managed for you. So all you have to do is pretty much pick the service in the cloud that will be able to host and hold and manage your data for you. So on that note, we're going to go on to the first type of data storage that we're going to talk about, and that's databases. So relational databases organize data into rows and columns, and this data lives in a table. Now, the schema is essentially the blueprint of how this data should look in a table. And in some cases, these tables have some sort of relationship with each other. So on the right here, what we're looking at is an entity relationship diagram. And what it's doing is describing the relationship between these squares, which are the tables. At the top of there is the table name. And then in the white part of the box is the columns or the fields. And it's explaining and it's describing the database of a library. So you'll see normally entity relationship diagrams when usually there's a huge system, kind of like a library and things like that, to really describe the relationship between tables in a database. Now, there is a case where some of these tables will not have relationships, and that's okay too. But the way that these relationships are set up are through things called keys, and those usually reference a specific column that two tables have in common. So to kind of summarize relational databases, databases store tables, the tables store the columns and rows, and the schema defines how the data will look, and that includes the columns and how the rows will look. And the rows are going to be the individual piece of data that represents the columns. So whenever you want to grab data from a database, anything like that could be all the data, or that could be a specific piece of data, you're going to use a query. And this is just code that you write in a specific language, depending on the database, your type of database that you're using to grab this data from the tables. So on the right here, we are looking at a screenshot of SQL Server Management Studio, where the database that we're using is called Microsoft SQL Server. And here we're running 2 queries on some customers and some orders. So here, this is a little bit of a more involved query, but you can see at the bottom here the results of these queries. So the first one, that first set of rows is that first query, and the second set of rows is, or second query is that second set of rows. So this is being run on a desktop computer, but also you can also run these in the cloud. And some common databases are going to be MySQL, again, SQL Server, which is also called Azure SQL in the cloud, and also Postgres. That's only just to name a few. So another type of database is called NoSQL databases. And this is for data that won't traditionally fit into this row and column format, but will usually take on a hierarchical view in a set of collections. And the individual piece of data are going to be called documents. So on the right here, we are looking at an example of a document. So a collection will hold a set of documents, and those documents will have keys that describe what kind of data should be in that key, and that points to that type of data. So on the right here, that first key there, first name, is holding the value Paul, and then we can also add some additional information. And one of the really great things about NoSQL databases is that they don't really follow a schema. So if you need to add additional key here, so for example, say that there was a key for the person's address, you could essentially add it right there into the document. But in the example of a relational database, you're going to have to add another column. And sometimes that can add some complications depending on how the database and the table itself were built. So let's talk about some different ways that data is also represented. Databases are not really the only way that you can manage and store data. So data can also be files. And in computing, in cloud computing, we typically call this blobs, and that stands for binary large objects. And so a blob could be an image, video, or spreadsheet, pretty much anything that really wouldn't fit into any sort of database. Another type is semi-structured data. So if you have ever worked with JavaScript before, you've probably seen JSON, which stands for JavaScript object notation. XML and HTML is also a version of semi-structured data. Because HTML is, yes, a document, and so that's data, but also inside of an HTML file, you have the structure of how the document should look on the web. So semi-structured data has some sort of structure, but it usually does not fit into a database. Now we're going to continue on to the next slide here, and this is going to be the demo. So this demo is going to be a guest book. So for those of you who might not know what a guest book is, this is, if you've ever been to anything like a wedding or an event, or even stayed at a bed and breakfast or a hotel or even Airbnb, usually there'll be a guest book around. And what a guest book essentially is a way for visitors to write down their name, where they're coming from, and maybe a message in the guest book as well. And this is just, for, safekeeping, just kind of a way to kind of record someone's moment, a special moment in time. So when I was when I was younger, starting to use the internet, I remember guest books as one of the most, aside from chats, as one of the most easiest ways and coolest ways to interact with the website, because you're kind of leaving your mark on the site as if you were leaving your mark on a guest book. So what I've done is I've made a digital guest book of my nostalgia to kind of illustrate how databases work in the cloud. So if you go to the short link here, you can also chime in and sign my guest book as well. So now we're going to go on to my guest book here. And if you end up running into any issues, if you get any errors, be sure to just go ahead and just give it a refresh. So the way this is working is that when you enter your name, so you can see I've been doing a lot of tests here. I'll just do a test here. Hello, SDC. And I'll put my name in here. And if I'll decide to insert it into MySQL. And looks like it's a little buggy, and that's okay. So if I refresh this page here, let's see if I can see if anyone has sent any messages. And looks like there's lots of messages in here. I've forgotten about all about desk books. Thanks for taking me back 20 years. Oh, hey, thanks, Joseph, Surly Dev, Arnab. Hi, everybody. Oh, this is so exciting. I love this. So this website I've deployed on Azure, and it's using a technology called WebSockets to give me real-time updates on my guest book. And notice that depending on what entry you make, it'll tell you if it's coming from MySQL or Cosmos DB. So let's look at this in the cloud. So I'm going to just refresh this here. So let's give it a refresh. Actually, it should be fine. I'll just refresh it here. And I'm opening the Data Explorer. Now this service is called Cosmos DB, and it's a way for you to manage NoSQL data. And one of the coolest things about Cosmos DB is that you can decide on what type of API you want to use. So one really popular NoSQL database is called MongoDB. And that's what I'm using here. So MongoDB has this, setup of keys and values, and you can see this is kind of what my data looks like in the cloud here. So let's see another example of this in the cloud, but I'm going to use another SQL management studio here called MySQL Workbench. So I'm using, again, as I mentioned before, I'm using MySQL as my relational data and Cosmos DB as my NoSQL database. So what I'm doing here is I'm just going to run a query here. Notice that my select star from guestbook query here is really simple. So what this is going to do is show me all of the entries inside of my guestbook that I have here. Woo! Wow! Awesome! Oh, it works! Yay! I'm so happy. Thanks y'all. Thank you all for helping participate in my demo here. I'm so excited. Awesome. So one thing that I want to just mention about databases in general, like things like MySQL and SQL Server, is that there are ways for you to set up your database to be transactional. What that essentially means is that, say that maybe you're inserting a large number of rows into a table, and say that something goes wrong. There are ways for you to kind of roll back all the work that it did, so that you don't have anything like data overlapping or any data loss. So that's another really cool thing about databases in general. Another thing, really interesting thing about the cloud is that these data centers are in, all over the world. So, and one of the coolest thing about Cosmos DB is that it puts your data closer to where you can set your data closer to where your users are, and that kind of helps with things like latency. So your data approaches either you or any users faster. So that's it for the demo. But I just want to go back to the slides here and kind of talk to you a little bit about the resources that I have here. So in here is a link to the demo that I did, and it's a repo where you can kind of deploy these databases yourself and run it locally. It's built in Node, and it's still a little bit of a work in progress, so it might be a little buggy. So if you decide to fork it or make a copy of it or clone it, just be aware that I might be making some more updates to it. Because as developers, we're always trying to make things faster and more performant and improve on it. So yeah, and if you have any questions or or if you notice a bug, please feel free to add an issue in that repo. There's also more resources in there for you as well. And if you're interested in learning more about databases in general, and specifically, this link points to a relational database in the cloud that's very popular on Azure called Azure SQL. And it will walk you through kind of how to work with the Azure SQL database. So definitely check that out if you are interested. In addition to that, you probably have already heard about the Cloud Skills Challenge, but I would highly recommend that you definitely go and participate, because you can get prizes, and you can also get certifications, and you also can and you can also learn more about either the data or whatever is of interest to you in the cloud. And I will be on Twitch in a little bit here to answer any questions or concerns or comments that you might have. So definitely check out the Microsoft Learn TV, and also check out the Microsoft Developer Twitch. And I will see you there. And I just want to end with the 2 links that I was mentioning earlier. And my handle is Paladeep. That is on Twitter and on GitHub and on Twitch. So you will see this handle on Twitch in a little bit. So thank you so much for participating in my demo and for coming to listen to this talk. It's been an honor. I always love interacting with you all. So please feel free to leave an issue on my repo, or leave chat with me in Twitch. So bye. Thank you so much.